Assalamualaikum dan salam sejahtera. Today I will be presenting my topic on solving problems using computational thinking. In this presentation, I will explain how a non-routine mathematical problem can be solved using a heuristic approach together with computational thinking. This approach helps us solve complex problems in a structured, logical and efficient way. My name is Muhammad Akhtar Afifi bin Muhammad Asadi, and I from class Mathematics 2, and this is task 3 heuristic presentation for the subject computational thinking. Mathematics is not only about applying formulas or performing calculation, but it is also powerful tools used to solve real-life problems. In many situations, we are required to analyze the problem, think critically, and make decisions based on logic. Therefore, mathematical thinking plays an important role in helping us to understand and solve everyday problems effectively. There are two main types of mathematical problems, which are known as routine and non-routine problems. Routine problems are usually straightforward because they involve the direct application or formulas or standard procedure that we have already learned. In these types of problems, their steps are clear and predictable, so students can solve the problem by themselves. On the other hand, non-routine problems are more complex and challenging because they do not provide a fixed method or formula. Instead, they require higher order thinking skills such as analysis, reasoning, creativity, and decision making. Students must understand the problem deeply. Then, students also must explore different strategies and evaluate the possible solution before arriving at an answer. Therefore, non-routine problems play an important role in developing critical thinking and problem-solving skills. In this problem, a delivery rider is required to visit multiple locations and return to the starting point while minimizing the total distance traveled. This problem represents a real-world optimization problem that is commonly found in areas such as logistics, transportation, and delivery service. The main challenge in this problem is to determine the most efficient route among many possible routes. Since each route results in a different total distance, we need to carefully analyze and compare the options before making a right decision. This makes this problem more complex and realistic, as it reflects a real-life situation where efficiency and cost reduction are the most important. Why the problem is non-routine? This problem is classified as a non-routine problem because it does not have a single direct solution or a specific formula that can be applied immediately. There are many possible routes that a delivery rider can take. Each route will produce a different total distance. To solve this problem, we must think critically and strategically by analyzing the given information. We need to exploring different possible routes and making comparing for their outcomes. The process requires decision-making skills and logical reasoning to determine which route is the most suitable and is the most efficient. Therefore, these problems encourage deeper thinking rather than simple memorize of steps. To solve this complex problem, we apply computational thinking, which is a structured and systematic approach to problem solving. Computational thinking consists of four main components, namely decomposition, pattern recognition, abstraction, and algorithm design. Each of these components play an important role in simplifying complex problems. Decomposition helps us break the problem into smaller and more manageable parts. Pattern recognition allows us to identify useful relationships or trends. Abstraction also helps us to focus only on the main thing or the relevant information while ignoring unnecessary details. Finally, algorithm design provides a step-by-step method to solve the problem. By using computational thinking, we are able to approach the problem in a more organized and efficient way. In this step, we begin by applying decomposition, which means we need to breaking down the problem into smaller and more manageable components. For example, we identify the number of locations involved, the distance between each location, and the starting and ending point of the route. Next, we need to apply pattern recognition by analyzing the distance between locations to identify patterns or anything else. For example, we observe which locations are closer to each other, which path may result in shorter distance. By combining decomposition and pattern recognition, we are able to reduce the complexity of the problem and gain a clearer understanding of how to approach the solution. After that, we apply abstraction by focusing only on the most important thing, which is in this case is the distance between locations. We ignore unnecessary details such as traffic condition or environment factor, as they are not required for solving these problems. Then, we need to apply the algorithm. Specifically, a heuristic method known as the nearest neighbor algorithm. This method works by starting at one location and always choosing the nearest unvisited location as the next step. Although this method is simple, it provides a systematic and efficient way to generate a solution, especially when dealing with complex problems. Using the nearest neighbor method, we generate a possible route by starting from point A and selecting the closest location at each step until all locations are visited. After visiting all locations, the route returns to the starting point. Once the route is formed, we calculate the total distance by adding all the distance between each pair of locations in the route. This calculation allows us to measure the efficiency of the chosen route. The goal is to obtain the shortest possible total distance, which represents the most efficient solution. After obtaining the solution, it is important to evaluate the result by comparing it with other possible routes. This helps us to determine whether the chosen route is efficient and reasonable. The heuristic method is justified because it is simple, fast and easy to apply, especially in real-life solutions where quick decisions are required. However, this method also has limitations because it does not always guarantee the optimal or shortest possible solution. Therefore, while the solution is practical and efficient, it may still be improved by using more advanced algorithm or computational tools. In conclusion, computational thinking provides a clear and structured approach to solving a non-routine problems. By breaking down the problems, identifying patterns, focusing on important things, and applying a step-by-step strategy, we are able to solve complex problems more effectively. The use of heuristic method, such as the nearest neighbor algorithm, allow us to find a solution that are efficient and practical, even though they may not always be optimal. Overall, this approach enhances problem-solving skills and is highly valuable in real-life applications such as logistics, transportation, and decision-making. Thank you for your attention and for listening to my presentation. I hope this presentation has give a clear understanding of how computational thinking help us and we can apply it to solve a non-routine problems in a structured and accurate way. Thank you.